Okay, so the next three problems I want to look at are the three that are along the bottom of the front page, which are 15, 16, 17, just because they're a little different, and I want to make sure you guys understand what means what when we're talking about solutions. So number 15, we're going to start out by distributing the 6, and then we'll distribute the 3, so I'm going to go ahead and draw those in. So I have 6x plus 6, and then the minus 3x equals, on the other side, 3 times x, and 3 times 4, which is 12. Now, if you look on the left side, when I distribute, I've got some like terms to combine. So I'm going to go ahead and do the 6x minus the 3x and get 3x's. And then plus 6 equals 3x plus 12. Now I want to move all my x's on the same side. So I'm going to subtract 3x's from both sides. And you see what's left after I do that is all the variables go away, and all I have is 6 equals 12. Now, because we know 6 doesn't equal 12, then I know this equation is not possible, and there are no solutions to it. Okay, so no solutions happen when the number does not equal the other number. No variables are left, and all there are numbers, and they are not equal. Okay, so 16, again, variables on both sides, but I still have some like terms to put together. So 5x minus 2x makes 3x. So 3x plus 3 equals 8x plus 3. I'm going to move my variables, so I'm subtracting 3x's from both sides. So that leaves me 3 equals 5x plus 3. Then subtract my numbers, my constants. So 0 equals 5x. Now some of you might be worried here because we have a 0, but that's okay. 0 is a regular number. I'm going to go ahead and divide by the 5, and 0 divided by anything gives us a value of 0. So just because you see a 0 in the equation doesn't mean that you can't have a solution or need to stop. Go ahead and keep solving just like you would with a regular or different number. Okay, 17. Again, I've got some parentheses. I'm going to go ahead and distribute. So 4 times x, and then 4 times 2, with my extra x added on. On the right side, 5x plus 15 minus 2, and then I've got like terms. So 5x plus 8 equals 5x, 15 minus 2 is 13. I'm going to subtract 5x's from both sides to get the variables together, and that leaves me 8 equals 13. So we're right back to just like we had in number 15. Okay, the variables have dropped out. I've got two numbers that are different. So again, no solutions to this equation. So what does it look like when we have infinite solutions? Because it's very similar to that. If I had something like, let's say 3 times x plus 2 equals 3x plus 6. So distribute 3x plus 6 equals 3x plus 6. Subtract my 3x's. And my variables have dropped out, but if you notice, I have an equation left that is actually true. 6 does equal 6. So this is when I would say all real numbers.